Hello，早。越来越离开。写生呢？来这吧。当然差不多一样的东西哦。那你找。我刚才划电话划到了。Thank you。So I thank you。觉得今天可以结束了。我今天明天蹦，我不会接受，我今天一定结束。结束掉这一刻。这星期有比赛，拜三。你要几时哦？哦，没有讲那个比赛到几时。还有那个，I mean，本科呢，就要比哦，就游泳是吧？啊，那就完了。哦，这么贴身的到下个礼拜，现在到这个礼拜。要玩在厕所。 哦，没有等他比赛啊，他比赛不是下个礼拜有比？
下个礼拜啊，
嗯，yes. 嗯 Where's the rest? Sleep. Huh? When? When's the quiz? Huh? Yesterday? 2 days. 1 day. Oh. Oh. One day one half 啊，没有啦，看加上打赛。输了，我你这个都是1个小时的，回去我就睡觉啊，很累啊。Okay, let's get started. Meme first. Yeah. So today this meme very important. Important to help you imagine. So let me mention about some concept first. Okay, so my goal is to finish multiple integral today. So the technique you need to know for this chapter, right? Okay, you need to keep few image in your mind. Okay, so you need to keep these different dimensional space in your mind. Okay, so what is zero dimension? It's just a point. Okay, what's the one dimension? Is a line. What's the two dimension? Example, plane. Okay, a square. How about three dimension? Cube. But what I'm going to tell you now is we can build higher dimension from low dimension. Okay, so how do you build a line? How do you build a line? Huh? You take infinitely many dot. Okay, infinitely many zero dimension. Okay, how to form a two-dimensional square? Okay, you take infinity line, infinitely many line. Okay. How do you form three dimension? Huh? You take infinitely many plane. Okay, so this tells you when you look at one direction, okay, you look at one direction, how the cross section of the object is. Okay, so if you look at this plane at x direction, okay, then you will cut out into infinitely many lines. Okay, infinitely many horizontal line. If you cut in the y direction, you will get infinitely many vertical line. Okay. Okay. So this corresponds to how you take the order of integral. Okay, you should keep this in mind when you cut the integral into cross section. Okay. Later we'll do something in 3D. So you need to cut different way. Okay, you need to cut into two-dimensional piece, and then from two-dimensional piece, you cut into one-dimensional piece. Okay. So far, got question or not? Later we'll see example. So far, got question? No? Okay. Okay. So before we go into triple integral, let's finish up this surface area. So to find the area of the surface, you just use this formula here. I think this formula will be given. So it's a multiple integral of square root, double integral of square root 1 plus the first derivative square plus the second derivative square. First with respect to x, second with respect to y, and then dA. Okay, so note that here you got an extra plus 1 here. Okay, compared to the arc length, the length integral, line integral. Okay, the length integral. Huh? No, central mass no need. Central mass no need. Yeah, application no need. Yeah, application no need. Central mass no need. And then there's one more, I think. Yeah, application no need. Yeah, throw away. No need. Yeah, okay. No application. Mass is not applicable. Okay, so surface area. So, okay, area of the surface. Yeah. So just briefly see how we apply this. So let's say we want to find a surface area of a surface z equals to x squared plus 2y that lies above the triangle region T in the xy plane with 3 vertices. Okay. Okay, z equals to x squared plus 2y. What is it? Some hyperboloid or paraboloid. Okay. So you want to look at this piece of domain here. Okay. So you need to differentiate what's the domain picture. Okay. And this is the graph. So domain is a triangle. Above the triangle, you have the surfaces. Okay, and then you want to find what's the surface area of this curve. Okay, so we just use the formula just now. So the formula just now requires what? So the formula just now requires the first partial derivative with respect to x and with respect to y. Okay, and then take square root. of 1 plus fx squared plus fy squared. Okay, but how to set up this domain here? How to set up the domain here? So you need to decide you want to do dx dy or dy dx. Okay, so you want to do dx dy or dy dx? Huh? Maybe try dx dy. Okay. So to do dx dy, right? Okay. So you need to tell me how y is bounded, and then how x is bounded by y. Okay. So do you know how to get this picture here? Okay, given 3 dot. So given 3 dot, you can draw a triangle. Okay. How to describe the line of this, the boundary of this triangle? You know how to get y equals to x here? Can do you know how to get y equals to x? Huh? Y equals to mx plus c. Okay, so you got 2 points here. Then you can find the gradient, right? You can find the gradient. What's the gradient? 1 minus 0 over 1 minus 0, which is 1. Okay. And then okay. So y equals to mx plus c. So what's the y-intercept? What's the y-intercept here? 0. Okay, so m equals to 1, c equals 0. Okay, but y equals to mx plus c, right? Is not very useful when you don't know the y-intercept. Okay, so what do? You could use another more general formula, right? Y minus y1 over x minus x1 equals to m is y2 minus y1 over x2 minus x1. Okay, so x disappear because here is a y-intercept. Okay, so you got this y equals to x. How about the horizontal and vertical boundary line? Do you know? Okay, so the horizontal line is x equals 0. The vertical line is, sorry, the horizontal line is y equals 0. The vertical line is x equals to 1. Okay, so if I want to do dx dy, where do I take my y from? Huh? Take my y from where to where? So 0 to 1. Okay, good. From 0 to 1. Okay, so now, once I take y from 0 to 1, how do I fix my x? Okay, look at the cross section. Okay, so this plane, this triangle here is made out of infinitely many lines. Okay, if you look at the x direction, sorry. Yeah, okay. So over y equal to 0, okay, the line start from where to where? 0 to 1, okay? And then when y ends at 1, what do you get? You just get 1. Okay, so what happened to the middle x? Between what? Between 0 to 1. So what do you take as your lower bound? Huh? 0? What did you say? Y. Okay, so you take y. Okay, if you take 0, what happened? What happened? What do you think? You don't know. Okay, so you get the whole square because for every y, you have 0 to 1, 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 0 to 1. Okay, so you get the whole square. Okay, so you need to cut it off using x equals to 1.
Make sense or not? Okay, because when y equals to 1, it is just 1 point. When y is 0, it is 0 to 1. And then when y getting smaller or getting higher, in this case, x getting smaller. Okay. Okay. So if I replace this y equals to x squared, what happened? Then the x is bounded below by square root y. Okay, square root y. Okay. Okay, let's see this is what I did or not. Oh, this is not what I did. So what I did is I used dy dx. Okay, so I fixed my x first, okay, from 0 to 1 also. So I look at how the x change, the y change. Okay, so the y is bounded above by x and then bounded below by 0. Okay, so these two should give the same answer. Okay. Okay. Yeah. Okay. How about next one? Any question on this one? Okay. I mean, two very important thing in this integral section is you need to know how to find your domain. Okay. Second, write your domain out. Integration should be not too hard, but you need to use the right domain. That'll be the hardest question. Okay. Next, find the area of the part of paraboloid z equals to x squared plus y squared that lies under the plane z equals to 9. Okay, so uh, okay, so first is this paraboloid here. Okay, it says that you want to find the area of the part under the plane z equals to 9. So you go to z equals to 9 plane, cut it off, okay, and then look at the surface area here. So how to find the domain? How to find the domain? How to find a domain? So let me write down the equation. Z equals to x squared plus y squared. So how to find the domain? How does the domain looks like? Huh? Parabola is the graph. Circle. Why is it a circle? Huh? Okay. Yeah. So you sub z equals to 9. Okay. And then you will get a circle equation. Okay. And then you know that everything under this plane, right, is inside the this. Okay. The pre-image is inside the this. Okay. Because this graph doesn't look like this. Okay. Since it is a paraboloid, you will see that this is the so you will see that the domain is this. Is it okay? Okay or not? Okay. Of course, this relies on you know the graph. Okay. How do you know the graph? Because if you test all the number below 9, you will see it satisfy a circle equation. Okay. For example, equals to 8 equals to 7, 6, 5, 4, 3, 2, 1, 0. Okay, so you can see that the range between 9 and 0, it is a circle inside this here. Okay. Okay, so last time, what kind of coordinate we have learned? Rectangular and polar coordinate. Okay, so in this case here, we have circle. So better we work with polar coordinate. Okay, work with polar coordinate. Okay, so if I write this in polar coordinate, right? How do I write? Our coordinate is r, the radius and the theta. So how do you control the radius and theta? The radius is less than equal to 3, and then the angle is everything 0 to 2 pi. Okay. Yeah. Okay. So why don't we work with xy? Do you know how to write out xy if you need to write this up? X squared plus y squared. Okay. So you can fix one of them first. Okay. And then you need to pick both. What do I mean by both? So y should be in between y minus x squared, something like this. Okay, so you can see this is the above is more easier because you just have 4 scalar. Okay, the bottom is harder, so we will use polar coordinate here. Okay, so we use polar coordinate. Okay. Okay, so this idea is actually the same as the parametric equation. Okay, you cannot describe a circle just using a function, but you can describe it as a function of polar coordinate. Okay, function of xy you cannot, but function of polar coordinate you can. Yeah. Any question? Okay. Do you know how to go from this to this description here? Radius and angle. Why? Uh, so my idea is you got this circle here, right? Okay. Got this circle here. So the top part is okay, not one, right? It's 3 actually. So this one change to 3 first. Okay. It's 9. Yeah, it's 9. Okay, so the top part here is y equals to square root 9 minus x squared. The bottom part here is y equals to minus square root 9 minus x. Yeah, this one, using this. Yeah. Okay, okay. Yeah, so my idea is, you see, r theta no need to depend on each other, but xy need to depend on each other. Okay. So using polar coordinate, we can just get rid of the variable and just integrate using the scalar. Okay. 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 So what's the function of surface area you need to integrate? Square root 1 plus first derivative square plus second partial derivative square. Okay. Okay. So in this case here, we turn our function into polar coordinate as well. When you introduce polar coordinate, right, you have an extra Jacobian factor. So what's the extra Jacobian factor? R. Okay, so you need to multiply by an extra R. And then you do the normal integration. Okay. Okay. Any question? So this formula will be given. So what you need to care is how to find the domain. Okay. And decide whether you want to use polar or you want to use rectangular. Okay. Yeah. Any question? Any question? Final answer is pi over 6, 37 times square root 37 minus 1. Minus pi over 6 or minus 1? Maybe you need to check. I think it's minus pi over 6. So I put a bracket here. Okay. Yeah. I mean, this answer is not too important, but you need to know how to set up your integral. Okay, you need to set up your integral. Okay, I think answer is quite important because some of the lecturers just look at the answer and then give you 0 mark. So yeah, you need to be careful a bit. Okay. Okay. Any question before we go to triple integral? So this is the surface integral. So you are integrating over square root 1 plus the first partial derivative square plus the second partial derivative square over a region. Okay. Any question? No. Okay. So let's go on. Okay. So last time we briefly mentioned this triple integral here. So now your domain is a three-dimensional space. Okay. So you have a box. So there are three directions to increase the number of the box. So you have these three limit here and three sum. Okay. So over every dimension, you can increase the number of boxes. Okay. So until you get the it's not a volume of graph anymore, you get a hypervolume. Okay, because that graph is live in R4. Okay, so last time we touched about this Fubini's theorem. So it's the same as a two-dimensional case. If you integrate over a box, okay, then you can exchange the order. Okay, you can exchange the order you like, any order you like. So there are three factorials of order here. Okay, dx, dy, dz, dx, dz, dy, and so on. Okay, so let's continue. Okay, how about we try this example again? So let's evaluate this integral where E is the solid tetrahedron bounded by the plane x plus y plus z equals to 1. X equals 0, y equals 0, and z equals 0. So this plane have what kind of normal vector? What's the normal vector here? 1, 1, 1. Okay, 1, 1, 1. Okay, so 1, 1, 1. So you can see that this plane has a right direction. Okay, 1, 1, 1. Correct or not? X is here, Y is here, Z is here. So this plane have a right direction. 1, 1, 1. Okay. Okay, so you have this plane and then cut off by this three plane here. X equals 0, Y equals 0, and Z equals 0. And so you get this solid tetrahedral. Okay. Yeah. So this picture here is a domain picture or a graph picture? Huh? Graph or domain? This is just a domain. Okay, this is just a domain. Now our domain is in R3. Okay, you can see that this integral here is a triple integral. Okay, so your domain have three dimensions. Okay, We can't plot what is Z now. Okay, we don't know where to plot it. Okay, so now we only can calculate it. Okay, so we want to do triple integral. So what sort of order do you like to do? So do you want to do x, y, z, ds, dy, dz, or what kind of order you like? Hmm? X, y, z. Okay. So let's try dx, dy, dz. Okay. So that means the thing that you integrate last, you need to fix it first. Okay, fix the range first. So fix z first, and then fix y, and then fix x. Okay. So how do you fix your z? Then let's say these points are not given, right? How do you find the highest point? How do you find this point? Intersection with the other plane. Okay, you intersect with the other plane here. Okay, x equals 0, y equals 0, and z equals 0. Okay. So for example, what? For example, for this point here, you set x equals 0, y equals 0, then you will get z equals to 0. Okay. Because this point here is lies between x equals 0 and y equals 0. Okay. The shape. Huh? Sorry, 1. Yeah. So y equals 0 plane is like this. X equals 0 plane is like that. Okay. So they intersect this part here. Okay. So z is going from where to where? To 1. Okay. 0 to 1. Okay. So now you need to fix the z and then look at the y direction. Okay. What happened to the y direction? Yeah. What happened to the y direction? So this is z. This is y. Z is going from 0 to 1. What happened to y? Y is also going from where to where? 0 to 1. Okay. So what's the line that bounds it? What's this line here? Z equals to 1 y. I mean, okay, so I'm looking at this plane here. Okay, what's this plane here? This slice is when x equal to 0. Okay, can you see it or not? Okay, can you see it? I look at this side here. This side here. So this side is when the plane is equal to the x is equal to 0. Okay, so when I look at x equals 0 here. Okay, this slice is when x equals 0. Can or not? Okay, so when x equals 0, it is z equals to minus y plus 1. Okay, so you can see that. How do you see this? Okay, so maybe I draw some picture for you. So this is x equals 0 slice. Okay, how about x equals to 0.5 slice? Okay, so maybe it goes somewhere lower, okay, and then shorter in y, and then it is a same slanted height. Okay, so I mean, I'm looking at this part here. 0.5 x equals 0.5. Can you see it? Can you see it now? So you cut this tetrahedron into triangle. Cut this tetrahedron into triangle until you reach a single point. Okay or not? Uh, see some confused face. Okay, so when I fix the Z, okay, when I fix the Z, I look at the slice on X. Can see it? Okay, so this is just the X equals 0 slice. Yeah, okay. So what's my Y here? So my Y here is bounded above by 1 minus Y, sorry, 1 minus Z, and bounded below by 0. Okay, because the lowest point you get is 0. Okay, get 0. Okay, 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 okay. So how about X? How about X? How X get controlled by both of these? So I think for X, right, the easiest to see is the lower bound. Why? Because for every Z and Y you have, you must touch X equals 0, you see? You must touch X equals 0. Okay? For every Z and Y you have, it must touch X equals 0. Okay? But how about the upper bound? Hmm? Upper bound is a plane. Okay? So upper bound is just the original plane, which is which is 1 minus Z minus Y. Yeah. So the upper bound is the plane. Okay. Okay. So in this case here, you need to fix a Z. Okay, fix a Z direction, fix a Y direction, and then you look at the X. Okay. Is it hard to picture here? So you fix the Z direction. Okay, you fix the height first. Okay, and then you fix the Y, and then you look at the X direction. Okay. Can you picture this or not? The last one. Cannot. Okay, cannot. Let's see how to work it out. Okay. Uh, let's see how to work it out. Okay, so you fix the Z first. Okay, you fix the Z slice, and then you see how Y and X change. Okay, I mean, let's pick some point, right? Let's pick some middle point. Okay, Z equals 0.5. Okay, so okay, let me try something fancier. Okay, first of all, okay, wait. Okay, let's fix this. So let's fix Z equals to 0.5. Okay, and then what we have is uh what we have is so we got something in XY plane. Okay, XY drawn in this way, X and Y. And then we have this triangle here. Okay, how about P Z equals 0? P Z equals 0 is the largest one. So let's P equals 0. So here we got 1, 0, 0. This is X, this is Y. And 0, 1, 0. Okay, so this is this line here. And then your Y. How does Y change? Okay, how does Y change? So Y change from 0 to 1 minus Z. Okay, so we need to pick a Z, pick a Y. Okay, maybe we can pick some other Y here. Z or Y equals to 0.5. Okay, let's use other color. Y equals 0.5. Okay, so the question is, how does this X changes? How does this x changes? Okay, so imagine, so now you need to put some computer into your mind. Okay, so over every height, okay, over every z, okay, you have this piece of triangle getting smaller, 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 smaller. Okay, so you need to keep this in your mind first. Then we select a layer out. Okay, we select a layer out. We select a triangle layer out. Okay, and then now we fix y. Then we fix y. Okay, along each y we look at the x direction. How this changes. Okay, you can see that if I fix different y, this x changes, right? Okay, so how does this changes? Okay, the claim is the x will change with 1 minus z minus y. Okay, so why is this line 1 minus z minus minus y? What's this line here? This line here is exactly line on the plane. To be on the plane, you need to satisfy the plane equation. Okay, so this x tells you that over every z, it will change. Okay, over every y, it will change. How to change? Change based on the plane equation. Okay, how this part changes? Use the plane equation. Can get it? No. Okay. I repeat again. Repeat again. Okay, very important. This example very important. Okay. I repeat again. So now the order we do is x, y, z. Okay. So now we need to fix z first. Okay, I agree. Agree now. Okay. So if you fix z direction, what do you get? You get a horizontal triangle. Make sense or not? Okay. So over each z, right? You get this z, get the triangle getting larger and larger from top to bottom. Can or not? So you slice. So you got the tetrahedron and then you slice it. Can or not? Can. So this okay. This solid is look like this solid looks like mm, like this. Okay, so this is a solid like this. Okay, so you cut it horizontally. So you got a point and then triangle until you reach the largest triangle at the bottom. Okay, so I draw this the largest triangle out. Okay, the base. And then next step, you look at every y. Okay, fix the y. Okay, fix the y. And then you look at the x direction. Okay, see how this x changes. Can see or not? Okay. Okay. So the problem here is, what is this line here? Okay. How does x get bounded by this line? Bounded by 0 and bounded by this line. What is this line here? Where does this line lies? This line lies on the plane. Z equals to 1 minus x minus y. Okay. So this in particular, this line have to satisfy the line equation. Line equation. Sorry, plane equation. Okay, plane equation. Okay. Yeah. So x is bounded below by y minus z minus y. Okay, because here is a larger x, here is a smaller x. So you go from smaller to larger, smaller to larger. Okay. Okay. So in particular, what does this tells you? This inequality tells you the x depend on z and y. Why? Because over each height, over each z, you have a different x. Okay, because your triangle getting smaller, smaller, and smaller. And then this x here will change depend on which slice of y you take. Rainy also start already. If rainy start, then everyone start already. Okay, I mean, can you follow the procedure or not? Somehow, kind of. Uh, you can digest it later, but you must be able to follow the procedure first. You need to remember what becomes smaller, what becomes smaller, and then later you will think back again and then see why is it true. Okay. So the idea is very important from this order here. This really depend on the order you take. Okay. This is very dependent on the order you take. Okay. So if you fix Z first, then you cut at each Z. Okay, you cut at each Z. And then next, you look at each Y. Okay. And then see how the last variable change. Okay. The claim is this line here is 1 minus Z. So X equals to 1 minus Z minus 1. Okay. So this is the base of tetrahedron. Okay or not? A question? Ask question. Don't know how to ask. Okay. Yeah. Okay. So you see the starting idea just now. The starting idea just now 3-dimensional, right? Okay. If you cut down 1-dimensional, you get 2-dimensional. Okay, 2-dimensional things here is triangle. And then if you cut further down, it become 1-dimensional. So it becomes lines. Okay or not? So you start with a 3-dimensional object, okay? This tetrahedron. If you take a slice, you cut down 1 dimension, okay? So you get this 2-dimensional thing, okay? And then you cut further down, become 1-dimensional, become this line here. So let me draw a line. Or this line here, okay? Okay or not? First, you need to know how to cut these things out. Second, you need to determine what's the range, okay? First, you need to know how to cut it out first. Second, then you need to determine what's this range here. Okay. So the range here is this plane equation because this line have to live on the plane. Okay, so this line have to live on the plane. So let me draw this. So so what? So so let me draw this line as green. Okay, so let me draw this line as green. Okay, this bounded line is green. So where's this green line here? This green line here is here. Okay. Okay. This green line live on the plane. Live on the plane. Okay or not? I sliced everything out already. Chinese say 大蟹8块 more than 8块 here. Slice into add slices. Add pieces. Okay or not? Okay. Lost already. Any question? How to what? Yeah. Okay. So once you have this range, right? Okay. Once you have this range, you just arrange the integration domain. Okay. So for z, you integrate from 0 to 1. Y is 0 to 1 minus z. X is 0 to 1 minus z minus y. Okay. And then you do the normal integration. This question here, you get 1/24. I suggest you to try with different order of cutting. Okay, try different order of cutting, and then check that you actually get the same answer. Huh? You want to try? Okay, okay. If I spend too long in this question, right, maybe some question we have to skip. You want to try cutting this in different way or not? Different shape, but this one different order, also different. I mean, it's the same, but I mean, okay, there are two things here. Okay, I'll do both of them. Okay, do both of them. Okay, do this and then do the other question also. Okay, so let's try this in another direction. So Chiesen say want to do, so you pick one order. Huh? Y, X, Z. Okay, so you want to Y, X, Z. Y. So let's do Y, X, Z. Okay, let's see how this diagram get cut if you use Y, X, Z. Okay, so if you do Y, X, Z, right? So first thing you need to fix is Z. Okay, second thing you need to fix is X. Then the next thing you need to fix is Y. Okay, so based on the intersection point we found just now, where is our Z? 0 to 1 again. Okay, how about X? Okay, so to look for X, right, you need to form a diagram between Z and X. So what's the relation between Z and X? Okay, what's the relation between Z and X? So let's pick one slice. Okay, you see why there's a lot of slice. Okay, so this direction is cutting in this way here. Okay, so let me write down. So this direction of cutting our tetrahedron is let me bring it down a bit. So we cut our tetrahedron in this way. Okay, so in this direction here, in this direction, make sense or not? Yeah, in this direction. Now we are in this direction. Okay, so we keep the ZX plane. Okay, so when we look at the Y equals to 0 slice, what is our Z equals to X plane here? So Z is going from 0 to 1 as suggested. How about X? How about X? Also 0 to 1. But how do we connect these 2 points here? How these 2 points connected? Z equals to 1 minus X. Okay, so Z equals to 1 minus X. Because this line also lies on the plane. Okay, lie on the plane. Okay, so in this case here, what is our X? So if I fix Z direction, how my X change? See how my X change? Okay, depend on my Z. So how to depend on my Z? When Z equals to 0, 1, it is just 0. When my Z equals 0, it is 0 to 1. Okay, so what's this bound here? What's this bound? This X is bounded below by what? X is bounded below by 0. Okay, bounded above by 1 minus Z. Okay, okay or not? 1 minus Z. This line here is 1 minus Z. Okay, 0 to 1 minus Z, 0 to 1 minus Z, 0 to 1 minus Z. Okay, make sense or not up to here? Make sense? Okay, okay. Okay, how about next step? So if you fix Z, if you fix X, what happened to my Y? So what happened to my Y? Okay, so you fix Z. Okay, so you fix Z, become this. Okay, so let me draw a diagram. So if you fix Z, you want to look at what happened to XY. Okay, you also look at the horizontal triangle, X and Y. Okay, so you fix Z. Okay, you fix Z. What happened to my XY? It's the same idea as just now. Okay, so go all the way from the top Z to the bottom Z, the triangle become larger and larger. Okay, so we just pick the easiest slice. We pick the slice at Z equals 0 and then see what happens. Okay. Okay, so in this case here, what happened? You fix Z and then you fix X and then you look at how Y changed. So this line here becomes what? So you fix X, you see how my Y changes. So it becomes this. Okay, become this line here. Okay. So you fix X and then you see how the Y direction changes. Okay. So how this Y direction changes. So this Y direction is bounded below by 0 and bounded above by this line here. What's this line again? The plane. Okay, because this have to live on the plane. Okay. So this equation is Y equals to 1 minus Z minus X. Okay. So the above here is 1 minus Z minus X and bounded below by 0. Okay. So what happened here? Okay, what happened here? So so this no longer live on this plane. Okay. So the slice here no longer live on this plane here. So you live this way. So you cut in the other way. So you cut in this way. So let me draw it. So wait. So you cut it in this way here. Wait. Okay, so you cut this way. Okay, so you cut this way. Okay. Yeah. Okay or not? Okay. Yeah, you can try more. You can try more. Different way of cutting. Okay. You also can cut Y direction first and then cut X and so on. Okay. You will experience different cutting of this solid here. How was it? Any question? Should we take a break or go to one example first? Breakfast? Take a breakfast. Okay, take a break. We can break until 9 o'clock. Wait. 9:10. What？
这个不是很前面
这个是哪一个
？dx dy dz 不是很前面，
？dx dy dz。
根本是从上面切下去的。你是从这里拿线
OK， 是。I mean， 没有，我 OK， 等一下，这边有两个东西，其实有点乱，但是呢，我要做一件事情，我要把这个换掉，要把这个换掉。对，来讲这个，讲我看哪一个？
如果是看 dx dz dy，
对，
我不是，对，假如这里是墙壁啊，就是这个
对
z 跟 y 是一个墙壁，
对，
我是从墙边的切这过去到。
对。但是我这个青色的东西啊，我不是在指这个切，我在指这一个帮。我在指这个帮，因为这是我是放青色，我是指它。我刚才要强调是这个东西在这个 plane 上面。
就是我可以这样子看的，不是？
就是，哎，你的对，你在讲这个红色线，对不对？
啊，
对，然后你是这样子，这样切咯，这样，没有错，你
如果我这样子看可以吗？就是好像是
那个
我拿一个点是好像是一个墙壁样子，
，yeah
就是我是从后面开始看，
yeah，
因为我知道后面的那个条线会被这条线影响嘛，就是
你要做梦，
就是我要看它是怎么去嘛，不是，就是好像它从这里到这里，如果我们拿每个不一样的 x 的话，它是这条线会变嘛，不是？对不对？
然后呢，
这样子的话，如果我看它 plane 的话，中文不可以直接看这个 plane 的，不是？我直接拿这个 plane 的也可以，因为它是跟这个 plane 改的，不是？
对呀，对，
也可以这样子看的是，
可以啊，然后呢，
但是好像是如果是这样的题目呢，
这个题目啊，等下我一做，等下我们做，
这个看法跟这个看法就不一样啊。
看你怎样切，看你怎样切
这个是不是用几度表？
啊，
知道是不是用几度表？几度表？
基础标是什么？
波拉克定理。
高级的，这个是用 Cylindrical 拖拉只是带2D 嘛，这个是用 Cylindrical。
这还是用
为什么这题出现在这里啊？啊？为什么这题出现在这里？
好问题，
就是你要讲嘛，
这题我本来是要在后面做的。
拿掉我这边，这还是用常规 x y 的，然后我这边。
常规的话，你就要去积那些 square root 东西。
那要不然波拉
要，
用它，我觉得也是。那个都像
这个怎么这波拉？
这个怎样换成波拉哈？这个
可以吗？反正这个你要怎么换？
这个没有，你看这个是三维的东西来的，其实，所以怎么说呢？你看啊，你只要有这一圈东西，不是你有了这一圈，不是？你看你 extend 的话是一个 cylinder 来的，所以你的 cylinder 只要切掉下面这个部分就可以了。下面这个部分是被这个 describe 嘛，所以你 bounded below 把这个，等一下我们会讨论这个。你一开始是一个 cylinder，如果从这个开始 start 了，但是你不拿 constant 的话，你拿一个 bound 就是这个 bound。
这个公式你有推导过？
没有推导过。
没有推导过。
那讲对。
我知道那个就是我们不是迟点来嘛？对，上个前10分钟讲。
没有，全部都在讲怎么用这个吧。OK， 我们重点在讲怎样 form 这个 domain。就这个 domain 的东西，横跨整个 topic 都要用。我们都在讨论怎样 form。
然后前面它就是有道题，它用基数标，就这道题的话，它这个积的话，刚好对 x 方加 y 方加啊。如果说
如果不是的话，
不是我的意思说，如果它到最后有那种 cos 西塔 sin 西塔这种，也就这样积也能做出答案出来，就是。
你先 change variable 去 cos theta 跟sin theta，然后再做这个。
对，如果说弄出来有那个 cos 西塔 sin 西塔也西塔就行了，是吧？就是一般来说。
没有啊，你就要正常积哦，
就正常积了。
要正常积，就正常积。
这种情况刚好那西塔刚好没了。
对，没错。
没错。
然
后就是这个公式考试的时候会点。
是吗？
我会发那个 formula 给你们看。
真的有用啊，那 formula
有，一定有。没有用，你不知道里面要错误。OK， 等一下结束前，我给你们看一个 video。
那个 video
给我看一个 video。
我要找
看 video
会考的考我们会听到，
不是，
看懂这个戏了，我已经知道了。今天知道你给我看懂什么？
等下给你们看
那个作弊那个，
感觉就是不是什么好的。
有什么一两个？
这个没有用，这个没有用。什么 central match 都没有用。
还有什么不用用？这个也不用用。
这个有用，这个
好用啊。
这个好用，等一下会讲，直接讲啊，我觉得我要直接讲那些东西。
直接讲一个，
就是那些 triple 那些。
是想问那，因为那时候没有来。其实这个有什么用？ 要看前面有点空，因为没有写东西。这个虎比例是哪一个？
虎比拿来做梦就是你可以 change 它的 order。刚才我们有讲啊，那它可以 change order，所以你看我们一直 change order。虎比例是可以 change，
是这样子吧？是这样子，这个有人吧？是吧？
就是你 over 一个 rectangle， 你就可以如果 continuous over 一个 rectangle， 就是不用我帮你 sign 了。然后它就 change order 了。
本来这个去order的时候啊，是很看情况啊，不是？
情况就是它只要是 rectangle， 它 continuous 它就可以 change。
我们的 rectangle， 这个样子的 rectangle。如果是三角形就不可以。
可以，但是它有一些 proof， 但是可以。
也可以。
我们现在就在做这件事情，但是我没有告诉你啦，I mean， 就是可以，因为你可以把三角形放在 rectangle 里面。OK，
这样子，
因为你
这
驾驶定底婆，这是来进场两种。
这个好像你转去 Polo 考定了，不是？
这个
没有转不是？对，
这个没有转，因为这个不破啦。这个可以破啦。这不破啦，
三角形。
因为为什么？因为你如果破啦的话，你这边会画出一个那个但是它不curve嘛，这样你又要把那段丢掉，这样不是很麻烦？对，
也是可以啊，只是要麻烦多一步做法啊，是不是这么说？反正数学家就是喜欢这样子嘛，复杂化再简单化，对不对？
没有，我们喜欢简单化。
没有，你们就是把东西变复杂，那边叫做数学出来。
就是跟你讲那个square root 派那个，要变得复杂，要变很简单
啊，是不是？你看数学家就喜欢做，
但是问题是他一开始很复杂。
你看牛顿就是没有想过为什么苹果会掉，他没有想过为什么是苹果不是榴莲。
他住在英国
啊，
如果住在 Asia， 他就是
也是有沙漠的嘛，
是。
他住在马来西亚，
就是什么情况下你可以把可能 integrate x integrate y。
什么意思？
你可以这样子变成这样子这样子本来是这样子嘛，不是？他们有时可以变成这样子。
那个是那个，如果你不是那个不是普比尼，这个，就是你那天没有来哦。
就是来没有，就是很对哦。我每次来没有来就是很重要的东西啊。
在哪里啊？不对，
那个可以说
这个，
这是应该乘法才可以，是
乘法才可以，猜不出就不可以。
对吧？
因为为什么？如果你去
independent，
因为如果你真的去做的话，它也是被拉出来，因为你 treat 另外一个 as constant 嘛。
就是我不懂啊，我是从 probability 这样子理解出来。它如果它是 independent variable 的话，就可以猜；如果它不是 independent 的话，它就
没有，因为那个是 partial integration 跟那个 partial derivative 啊，你做 integration 或 differentiation 去另外一个 variable 和另外一个是不等。
变成 independent 吗？不然讲它 independent。
可以，但是我们的 definition 可以，但是我们的 definition 是这样。但问题就是你的那个 variable 是 independent 才可以这样做，如果不 independent 就不可以这样做。
对。
但是如果为什么这样做是我们定义的。
你们定义了，
我们定义了。你是 independent 你才可以这样做。OK， 明白。
怎么你不要看一下我上次
没有啦，我先来。
还有讲是挨的其中一方，因为一方是的话就会那里
你不怕一点，
是我的 S 是
可以，但是要看你从哪一个方向。可以，但是问题是你要，可是你要那个整套，你要有整套的东西。你现在是从什么开始看？你是看 X Y Z， 对不对？如果可能你看 X Y Z， 可能你如果你看 X 的话 ，X 是 fix 从然后Y 的话就是
所以我不可能这里是
对 X 到 X，
0到 F 也是可以的，对，它这里有
0到 X 是可以的。
X3到
0到 X， 你给我看一下啊。我看 X Y Z 的话，我有做过。
不对 ，I mean 没有，这个是 depend on 你怎样去切它，你不能够单单只看，我看一下啊，
玩了一把 ，OK，被我输掉。
你是什么？你说零到 x，
x 是设为0到1嘛？
对，没错。
哦，那 y 的话可以是0到
但
x，
是这点我没有玩过，但是我的我还是有会的。
所以你要 try 哦，你要 try 那个 y 是0的时候，它在哪里？
是0的时候，
啊，不是 x 是 OK，先能不能先写一下 x 是从0到1？
还没有看题目。
对吧 ？OK， 然后你刚才另外一个想法是 x 到1，对不对？所以你看一下 x 等于0的时候，这两个给不同的东西，这个给0，这个给0到1，所以 x 等于0的时候 y 是什么 ？y 是0，对，
哎呦，这很快哦，你好吗？
所以应该要是0到
有可能
x 吧。
我靠第一题不想转，然后看第二题，哎，好像会哦。
可是 x 等于0的时候 y 是0，那这个0在这边。
它会给0到1，你 y 就要从0到1。没有。OK， 现在我的意思是说，你看啊，这个 x 啊，它 fix 每一段 y 怎么变？
0到 x，
对吗？但是 x 这一个会给出什么图片？这个好像会给出大面一块啊呀。OK， 好了 ，OK，testing，OK， good。OK， I'm not following the order in the lecture. I'm following my own order. So similarly, we skip the center of mass. Skip the center of mass. Okay, so now I want to immediately introduce two more coordinates. Okay, let's introduce two more coordinates. One is cylindrical. Okay, one is cylindrical. So in the cylindrical mode, why do we consider cylindrical? Okay, some picture I want you to keep in mind. Okay. If you are too tired, right? Second hour later, I show you a video.
榴莲那个榴莲大到榴莲头上。
OK，
然后看这个，
Okay, so we have three. Okay, I straight away introduce to you three of them. Regular coordinate, cylindrical coordinate, and spherical. So a bit, okay. Just name only name first. Again, the name. Cylinder, correct or not? Cylinder. Okay, correct. Maybe put into adjective, cylindrical. Okay, so rectangle. Okay, what is rectangle? So in rectangle coordinate, right, we use x, y, and z. Okay, so x, y, and z is what? So we imagine it as a box. Okay, just now all the Riemann sum is defined using the box. Okay, the limit of box. So you can cut box in 3 directions. Remember? Okay, how about cylinder? Okay, so you can see that this rectangle can fit into every point can fit into a rectangle. Yeah. Okay, so you can imagine this rectangle become bigger and bigger. And then smaller until a point at the origin. How about cylindrical? Okay, we also can describe every point using cylinder. Okay, every point live in some cylinder. Any angle also same. So what is it here? So here we have what are the three variable we have? We have radius, angle, and height. Okay. So this one is height. This is radius. This is angle. Angle on angle from positive x-axis. This is the same as the polar coordinate. Okay, so how should you imagine? So all of these are x, y, z, by the way. They are all x, y, z plane. Similar to the parametric equation. Okay, so how should you imagine this? So you should start with an xy plane. Okay, start with xy plane. You can describe everything in xy using polar coordinate, right? Okay, so using this circle here with all the radius. So my radius is going from 0 to infinity, and angle is going from 0 to 2 pi. Okay, so you got all this circle. How to fill out the R3? You need to introduce different height. Okay, you put this circle at every layer. And in this way, you form the cylinder. Okay, cylinder is infinitely many circles, correct or not? Okay. Okay, so where is my z? My z can be from negative infinity to infinity. Okay, not that you cannot take infinity, but you can approach it. Okay, how about cylinder? How about cylinder? Spherical. Okay, so you can fill every point. So every point lies on some spherical, some sphere. Okay, this is similar to the circle but higher dimension. Okay, so every point live in some sphere. Okay, this sphere will grow. Okay, so in this case here, we also have three variables here. So we call it rho, theta, and phi. 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 Yeah. Phi. Phi. Okay. Yeah. Okay. So rho here is also radius of sphere in this case. Okay. Just now is a radius of circle. Now it's radius of sphere. Okay. So you got a radius from origin rho. What is theta? Theta is also angle from positive x-axis or positive x-axis. Positive x-axis. Okay, now the third one, you need to compensate the height. How to compensate the height? Okay, how to compensate the height? This is not height anymore. This is the angle from positive z-axis. Okay, from positive z-axis. Repeat clockwise. I think it's a clockwise. Here is a clockwise. So what I'm saying is this is the phi here. Phi is here. Okay, phi is here. Okay. Phi is a direction from Z. Okay, so to fill the whole R3, right? Okay, what is the range of phi, theta, and rho you need to take? What kind of radius you need to take? 0 to infinity, similar to the polar stuff coordinate or similar to the cylindrical coordinate. You cannot equal to infinity. How about angle? You also get 0 to 2 pi, okay? So you also take 0 to 2 pi. How about phi? Phi. 0 to 2 pi, okay? If 0 to 2 pi, right, you will get too many stuff inside your space, okay? So the claim is I only take 0 to pi is enough, okay? So you just take 0 to pi, and then you got 0 to 2 pi, and then you can extend radially radius. What do you mean times 2? Okay, so let me draw the diagram I'm trying to say. So you have 0 to pi, okay, on the phi direction. And then you have 2 pi direction. You should think of the fan. Okay, you have the sayap. You have the wing, right? You have the wing. And then you turn 0 to 2 pi. And then you extend radially. Imagine or not? Huh? Hey, sorry, this is phi. Huh? What? What do you mean by phi and angle? Phi form this angle from positive z-axis, okay, 0 to 2 pi, okay, and then you have a radial angle 0 to 2 pi, so you turn this wing, so you will form the sphere already, right? Correct or not? Can you imagine? Can you imagine? Okay. So how you cut the sphere out? Come back to the basic question. How you cut the sphere out? Okay, you can cut the sphere like this. Correct or not? Let me try. Yeah, cut the sphere. So the sphere is like this. Can see or not? The sphere like this. Can you imagine the sphere? This is the sphere. This is the sphere. Can you see this sphere? Can you see? Seems like I'm an idiot. Can you imagine this sphere or not? So you need to patch this wing together, combine at the binding side. So this is the binding side. No. There's no left, right, up, down here because I cannot draw attached together. So I try to like move it a little bit away. But in your mind, right? In your mind, you should bind this side together. Wait, you should bind this side together. So so you should bind this side together. Cut the ball. Let me think. Cut the ball. The cat. Cut the cat also can. Yeah, cut the cat. Cake. Yeah. So you have a spherical cake. Okay. You got a spherical cake. Okay. So you cut it. How do you want to cut? You just I have a ball here. Yeah, how you cut it? So you just cut it half, keep cutting it into half in different direction. Cut it into half. Okay. Let me try something else. Okay. Okay. See this ball from here. Here is the top part. Okay, and then you cut it like this. So you cut it like this. Can or not? Okay, cut until you can see this slice here. This slice. I think you can somehow imagine as a watermelon. Okay, watermelon is like this, right? Okay, but what I want you to imagine is something like, actually you can think of it as a watermelon. Yeah, watermelon. Okay, so watermelon is like this. Okay, let's use watermelon then. I think you guys like to eat watermelon. Orange also can. Yeah, okay, watermelon like this. Okay, watermelon. Okay, and then you use this watermelon and then you put them together into a sphere. Okay. Okay. Yeah. Yeah. Is that one? Yeah. That's one. Yeah. So you put a watermelon here and then you form back your watermelon. Orange. Yeah, orange is closer. Okay, orange. Okay. Yeah, orange. Sunkiss, have to use Sunkiss. Sunkiss orange. You don't know. Next time you go to the supermarket, you say, I want to buy Sunkist. All right, Sunkist. Okay. Yeah. Sunkist. Yeah. Okay, why is it 0 to pi? So you can see this watermelon here, right? Okay, you see? So we should think of this watermelon here as a Z. This is a positive Z direction. So you only have 0 up to pi here. Okay. Okay, if you like, I turn this watermelon around. Precise. Yeah, like this. Okay. Yeah. Okay. So you have this watermelon and then you 0 to 2 pi around. Okay, so let me draw this 0 to 2 pi. So for here, so this is a 0 to 2 pi direction. X, Z. Okay, 0 to 2 pi. 0 to 2 pi here. Okay. So you have 0 to pi from the Z direction and then 0 to 2 pi XY direction and then increase radially. So you get the whole artery. Okay or not? Okay. Okay. Okay, so you remember watermelons. A spherical watermelon. Huh? Phi, remember, is calculate from the positive Z axis. Okay, positive Z axis. One is a XY plane, the other is a positive Z axis. From positive Z axis. Then positive here. Yeah. Yeah, 0 to pi. Clockwise. Clockwise. Clockwise.
就可以把它想象成地砖了。我可以把它想象成地砖了。
谁在自转？
地球的地砖，就是
没有，那个是 XY plane， 那个是地大，对。但是我是讲
当下的地砖，
也不是啊呀，对啊 ，yes。So if you just take 0 to pi over 2 and then you rotate 0 to 2 pi and then you get a hemisphere. Yeah. Okay. Right. Okay. Yeah, so if I give you every direction, you can put the watermelon back, right? But if you cut it half, you only have half of the watermelon back. To use a honey island maybe. Closer. Durian cannot. Okay.
If I want to make a then I can go into the right angle, right?
What do you mean I bet a top? Yeah. Later we will see it actually. Later we'll see that shape. Yeah, later we'll see the shape. Yeah, later we'll see that as a domain. Okay. Yeah, good. Okay, very good. Okay. So I mean the problem here, right? The problem here is how to go between these three. Okay. So we will only care about how to go from rectangular to both of them. Okay. So how to go from rectangular to both of them? So let me straight away do summary for you. Okay, so how to go between them? Okay, let's rewrite again. So here we got spherical. Wait. Yeah, we got spherical here. Rectangular. Why you got eyes to the back, man? Okay, cylindrical. Okay, so you got a XYZ in this case here, fxyz. Okay, so XYZ here, we cover everything from negative infinity to infinity. Okay, how about cylindrical? So cylindrical, we cover 0 to infinity for the radius, 0 to 2 pi for the angle, minus infinity to infinity for the height. Cylindrical, 0 to pi radius from 0 to infinity, and then angle from 0 to 2 pi, and then phi from 0 to pi. Okay, so how to go between them? Okay, how to go between them? So to go between rectangular and cylindrical, we use a formula similar to coordinate, polar coordinate. X equal to r cos theta, y equals to r sine theta. Okay, and then z equals to z. Okay, we keep the height. Only the xy will become polar. How about cylindrical? Cylindrical a bit complicated, but not too complicated. So x is equals to rho times sine phi cos theta, y equals to rho times sine phi sine theta, and z equals to rho cos phi. Okay, so you can see that. What can you see? So phi here control the z direction, angle between z direction. Theta here control the xy plane. Okay, so why is this long here? So one thing this xyz need to satisfy is it has to be a point on the sphere. Okay, so we have the point on the sphere. So is this a point on the sphere or not? How to check whether this is a point on the sphere? You just compute whether x squared plus y squared plus z squared is some radius square or not. Yeah, okay, it's a some constant or not. Okay, so we need to check this. So if we make this change of variable, do you think we have this equation here? Here's theta squared plus phi cos. Yeah. Yeah, right. So what do you do? Huh? What do you do? So what you do is you just expand everything out. You should see that first you can factorize phi rho square sine square phi. Okay, and then you get cos square plus sine square theta plus rho square cos square phi. Okay, and then phi square is you can substitute factorize again. Okay, and then you just get rho square. Okay, so you apply the trigo identity twice. Okay, so that's why you have this extra factor coming out. Okay, so you use trigo identity on theta, you use trigo identity on phi. Okay, so both you reduce to rho square. So this is a point on the sphere. Okay. I think so, but I forgot already. I will share you the formula sheet later. If don't have, also cannot have already. Submit already. Okay. Yeah, I think it's provided, but I can't remember now. But yeah. Okay. Yeah, I'll let you see the formula sheet later. Okay. So also in this case here, okay, points we can go between different coordinates. How about integral? Okay. Last time when we go between rectangular and polar, we got an extra Jacobian factor, right? Okay. So how about if we go between cylindrical? What do you think? Okay. So we have to first substitute our variable first, become x equals to rho cos theta, rho sine theta, and z, and then integrate over dz, d rho, d. Okay, just now use theta, then theta and theta z. Okay, just now we use r, right? So keep r. So we also have an extra Jacobian here, r. Okay, we also have extra Jacobian here. So you can notice that this cylinder is quite similar to polar coordinate. Actually, they are similar because you don't change in z direction. Okay, you just change in xy direction. But how xy change is exactly following the polar coordinate, right? Okay, because polar coordinate did these two, right? But z doesn't change. Okay, so the Jacobian is the same. Okay, but how about cylindrical? Okay, cylindrical is much harder. Sorry, spherical. Okay, spherical is much harder here. Okay, so you need to substitute all your x, y, z, and then differentiate with respect to d rho, d theta, and d phi. Okay, so the Jacobian here is what? The Jacobian here is square sine phi. Okay, if we have time, we will derive this Jacobian here. Okay, we will derive this. We will try and derive this if we have time later. Okay, so fast 937. Yeah, f is a function. Okay. So far, okay. We go into example first. Okay. Okay, we go into example. So the key things you need to remember here is how to change between these two. Okay. What domain is allowed. Okay. And then how to change between these coordinate. And then after you change, okay, how does this Jacobian change? Okay, this is the three things you need to address. What? Oh, this is a function in R and the phi, not constant. Yeah, part of the function already. Yeah, cylindrical is just R, just similar to polar coordinate. And then for spherical, you have R squared sine phi. Okay, sine phi, not sine theta, depend on the z direction, the angle on z direction. Okay, I mean, phi, theta, these are not important because you can rename them. So what's important is what's this factor here? This factor here is coming from the angle from the z direction. Okay. Okay. Name is not too important. The important thing is what does the name represent? Okay. Okay, let's look at examples. At this kind of coordinate change you guys want to do or not? Or can skip? I mean, okay, let's do it. Okay, wait. Okay, so let's do some exercises going from different coordinates. So let's say we got this cylindrical coordinate. Find the rectangular coordinate whose point of coordinate is cylindrical coordinate is this. So cylindrical coordinate correspond to what? And z. Okay. Now you want x, y, z. Okay. Now you want x, y, z. How to go to x, y, z? Yeah, similar to polar coordinate. So you want to find x, y, z, right? Rectangular coordinate is x, y, z. Given cylindrical coordinate r, theta, z. How to go from cylindrical to rectangular? The formula is equals to r cos theta, y equals to r sine theta, z equals to z. Okay, so given r, so you just sum 2 times cos 2 pi over 3, then 2 times cos, sine 2 pi over 3, and then equals to z equals to 1. Okay, so all together you get, and first you get 2 times minus half, and then second you get 2 times square root 3 over 2. So you get minus 1 and square root 3 and then 1. Okay. So note that these are the two exact point minus 1 square root 3 1, but there's a different way to write it down. Okay, you also can write down a spherical coordinate for this, right? Okay. Yeah. But can you go backward or not? Can you go backward? How to go backward? So I give you x, y, z. How you find me r and theta and z? Huh? X squared plus y squared equal r squared. Okay, good. So you can find r in this way. So after you find r, you can certainly find theta equals to tangent theta equals to 1 over x. Okay, good, very good. Yeah. So z is still remain the same, right? Z. Okay. Yeah. Can we skip this and then you check answer later? Okay, just skip this. This is similar to the polar rectangular stuff. How about spherical? Can you do it yourself? Rectangular to spherical, spherical to rectangular. I'll provide solution. You want to do it yourself? So going from rectangular point to spherical point, and then spherical point to rectangular point. Yeah. Okay. Yeah. Do it yourself. I think the most important thing is integral. Integral is more hunting. Okay, let's do integral. Okay, so this shape here, okay, integrate this domain, this function, bound over the region bounded by the parabola and the plane y equals to 4. Okay, so the picture here is a domain picture or a graph picture? It's a domain, just a domain, because your domain live in R3. Okay, you need R3 to draw your domain. This is just domain. Okay, so paraboloid is this picture here, and then y equals to 4, you cut at the plane. Okay, so which coordinate you think is easier to do for this one? So this one looks like a cylinder or looks more like a sphere? Huh? You think this looks like more like a sphere? So a sphere is something like this, right? Okay, but here is like cut off flat. Okay, here this part cut off flat. So if it is if it is a sphere, right, it should have something like this. Okay, like a cone. Okay, so in this case here, we will prefer to use cylindrical. Okay, why? Because you could see that this is a cut off cylinder here. Okay? You have a cylinder in this way, and then you cut off the bottom by this parabola. Can, but I mean it will result in harder integration. Okay, you also can use rectangular also can. You also can use rectangular, but you will you will get harder integral. But to solve the harder integral, actually you need to solve it in cylindrical also. Yeah, so it's the same actually. Okay, so for example, you learn in what? Learn in calculus, right? Learn in calculus when you differentiate square root of a squared plus x squared, something like that. But you go into tangent, right? Okay, so you are sort of changing the coordinate already. You already changed to another coordinate. Okay, so that implies you already changed coordinate. Okay. Okay, so let's do this. Okay, so how should you think of this domain here? You should think of some easy domains first. So either you think of it as a sphere, or you think of it as a cylinder, or you think of it as a box. Okay, so these are 3 basic shapes you need to know. So this one is, my claim is it is closer to cylinder. Okay, so cylinder looks like this. Okay, if cylinder looks like this, right? So you can see that the y direction get cut off by the bottom by the parabola. Okay, so how should I describe this? Okay, let me write down the thing. So for x, y, z, So let me write out my comment as well just now. So this is a part of half cylinder. Okay, so for our point to be in E, okay, so they must satisfy some condition, okay, some condition on cylinder. Satisfy. So first they must satisfy that the XZ direction, okay, is in a circle. Okay, what do I mean by this? Where the D is equals to the point in x squared plus z squared less than equal to 4. Okay. In other words, this is a this radius 2, the angle from 0 to 2 pi. Can everyone see this or not? This is the same example we started just now, but we turn it to the y direction. Okay, so if you have this paraboloid, right, and then you cut off as y equal to 4, you can see that everything below lies inside the this x squared plus z squared equals to 4. Okay, so this is the shape. Okay, and then how about y? How about y? Okay, how about y direction? Okay, y is bounded below by x squared plus z squared, bounded above by 4. Okay, so this line here is x squared plus z squared, and then here is y equals to 4. Okay. Okay. So far, okay. Yeah. Okay. All right. Everyone can read this new domain here. Understand how do we get this new domain? Yeah or not? Okay. Agree. Okay. So what happened to our triple integral here? Okay, what we will do is we will turn this integral. We can solve for y first. Okay, we can solve for y first. Okay, we can solve for y first. And then solve for the polar coordinate. Okay. Not that I ditch something here. Okay. Because if I were to use spherical cylindrical coordinate, right? My y here become the z just now. Correct or not? Okay, become my z. So I'm somehow like turn the spherical. Okay. I turn the cylindrical coordinate. Make sense or not? So this y direction become the z direction just now. Okay, but please don't be bothered by this. Okay, so there's no y direction in our integral, right? So what we can do is we just straight away integrate it. Okay, so we get 4 minus z squared minus x squared. Okay, how about the circle part of our cylinder? Okay, can you turn this thing into polar coordinate or not? How to turn this into polar coordinate? Equals to r 4 minus r squared times Jacobian factor r dr d theta. Okay, I mean in general, right? In general, how you do it? Okay, in general, how you do it? In general, how you do it? In general, you need to make the change of variable x equals to r cos theta, y equals to, sorry, in this case becomes z equals to r sine theta. Okay, and then y equals to 1 just now. So in general, you need to substitute this number in. Okay, let's say you don't have those identities, you need to compute the substitution. Okay. Okay or not? This represents how I get the first R. Okay or not? Change variable. Variable, you need to sub your change of variable in. Okay. Not just point become not just replacing the point, you also need to replace the function. Yeah. Okay. Okay, keep going. So in the d theta direction is 0 to 2 pi. R direction is 0 to 2. Okay, just now we fix 0 to 2 pi and then 0 to 2. Okay, the radius. Do you know how to compute the radius of the circle or not? Because the largest circle is x squared plus z squared equals to 4. Okay, so the radius is 2. Okay, and then you just solve this identity here, and then you will get 1, 2 at pi over 15. Yeah, any question or not? Any question? Any question? Okay, if not, I let you try one more question. Then after this question, we will take a break. So let's try one more question. Done. The answer is 1, 1 to add pi over 15. Yeah. 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 So try one more example and then we will take a break. So try this example. This example here. Which page? I don't know. I just jump here, jump there. You can just calculate this. I'm not sure it's the same or not because this one I take from MAT one. Yeah, because they don't have this center of mass thing, so I'm not sure it's tally or not. Yeah, if not, you just copy down and then do it. Yeah, computers. Yeah, I can try and integrate. Okay, 方舟、高启祥那些，江宏宇、李杰，OK，李培，OK，李玉章，连夜I think I saw you，天阳，平易，OK，刘平易，刘夏红，OK，凌波，I think 凌波 not here，OK，香鱼I think I saw you，施杰生one，OK， not here，清华 not here，宋子飞，王培武one，王宇轩，OK， you're not here，苏子凯 ，OK， Jingrong, I think here, Yan Jingrong. Okay. Zhang Yun. Okay. Dao Yixian. Dao Yixian. Dao Zikang, I think I saw you. Gong Jiaxuan, not here. Oh, here. Okay. Luckily, I got record. Okay. Hey, where's Daniel? Sleeping. Okay. Berwin. Ting Yi. Ting Yi. Haven't come back. Sleeping also. Ting Yi. Okay. 还是睡. Okay. Chia Ming I saw you. Sui Long. Okay. Pei Yu. Okay. And then Yun. Yi Hui. Yi Sun. Jia Seng. Dennis. Wen Kang. Wei Tao. Qing Rou. Ren. 冲凯杰 ，OK， 冲凯杰，申浩伟 ，OK， 郭七正 got， 吴宇 got， 吴承泽 ，OK， so how do you compute this integral here? Use polar coordinate, okay, good. This is a good idea to use polar coordinate. Okay, so do you know how to get this picture if this picture is not provided? You know how to get this picture here? Okay, so look at the integration domain here. You need to list out the integration domain first. Okay, so y is 4 minus x squared minus square root of 4 minus x squared. Z is going from square root x squared plus y squared to 2. Okay, so first you need to decide your x first, okay, and then decide your y. Your x, y, x is going from minus 2 to 2. Okay, so what's this range doing here? What's the range doing here? Okay, it's a circle. How do you see the circle? You can check the endpoint first. Check the endpoint first. Okay, so the other end is y equals to square root 4 minus x squared. And then the bottom end is square root y equals to minus square root 4 minus x squared. Okay, so these are the semicircle. Okay, so these are the semicircle. Okay, and then you can check that when x equals to minus 2, y is just 0. Okay, when x equals to 2, y is also 0. Okay, so you have something like this, 0, 0 here. And then the other side you got semicircle, the other side you also got a semicircle. Okay, and then next you can check that everything in between satisfy this inequality here. Okay, so this is a circle. Yeah. How about Z? Okay, how about Z? Z is a little bit harder to see here. Not quite. Not quite. It's a cone. Okay, how to see is a cone? How to see is a cone? You can see this Z here is depending on X and Y. Okay, how to depend on X and Y? What is x squared plus y squared square root? What is this thing? This is the length of your point. Length of your point, okay? So you see, so this Z here is controlled by the length of the point and 2. Okay, so you can see, if your point is the origin xy, okay? So what's the length of your point? 0, okay? So over the origin, you have 0 up to 2. Okay, you achieve everything 0 up to 2. Okay, but you can see that when this point get further away from origin, what happened? Okay, what happened? The Z becomes shorter, and shorter, because when you go away from the origin, you approaching the radius 2. Yeah, can see or not? For example, you pick a number. For example, pick this point here. This is the point 1, 0. Okay, so 1, 0 plug into the range here. What do you get? square root 1. So you get 1. So at 1, 0, okay, at 1, 0, you are starting from 1 to 2. Okay. Okay. So you do it for every point. Make sense or not? Make sense, huh? Make sense? Okay. So next question is, why is this a corner? Why is this a cone? Why? Because why? Because this is a Pythagoras theorem. Okay, z squared equals to x squared plus y squared. Okay, so you got x, you got y. Okay, and then you check the z height, the height of z. Yeah. So this is the Pythagoras theorem. Okay, that's why you got the straight instead of something curvy. Okay, so this is the Pythagoras theorem. Okay. 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 So the problem here is how to change this integral here. What's your domain here? What's your domain here? So you want to use cylindrical or spherical? Cylinder, right? Okay. Why? Because this is a cut off cylinder. Correct or not? Okay. So you cut off where? Okay. You cut off by the function z equals to square root x squared over y squared. Okay. So let's write down the cylindrical coordinate. I forgot already. I need to see. But try learn from scratch first. Learn from scratch first. Okay. So if you learn from scratch, right, you don't need to scale anymore. Okay, learn from scratch first. You don't know how to sketch, huh? Okay, so I also sketch from scratch just now. Okay, so let's ignore this. Okay, so first you start with the x direction. Okay, you first with the x direction. Second, you plot the y direction. Okay, plot the y direction, and then decide what's this shape here. Okay, just now we decide the shape here, right? We check the endpoint, we check the endpoint, we check the endpoint. Check every point at x. Okay, and then the hard part is the z here actually. This is the hard part. Okay, how you imagine this is very hard. Okay, if you are not given this. So first you need to realize that the range depends on the length of your point. Okay, depend on the length of your point. Okay. And then you see that when you go away from the origin, the range becomes smaller and smaller and smaller. Okay. So, but how you decide whether this is straight or not, this is the key problem already. So, but no matter it's straight or flat, this part here is always controlled by the function square root x squared over plus y squared. Okay, this is for sure. Maybe you don't know whether this is straight or not. Maybe this is curvy or what. But anyway, this is controlled by square root x squared plus y squared. Okay, to see that this is straight, actually you need to know that this is actually the Pythagoras theorem. Okay, Pythagoras theorem have the straight hypotenuse, right? Okay, yeah. Okay, so how to change this set of domain into r, theta, and z? Okay, first of all, z is easy to compute, right? Because z is just the same range. Okay, so z is going from 2 to square root x squared plus y squared. But there's a problem here. We don't have x squared plus y squared anymore. In this case here, it becomes r. Okay, in this case here, it becomes r, which is r. Like. Okay, so become r. Okay, good. How about r and theta? R and theta, how to control them? How to control R and theta? How to control R and theta? Here, this circle here. What's the radius of the circle? Okay, so you go all the way from 0 to 2. Okay, how about angle? Okay, you need to get a whole this, so it's 0 to 2 pi. R is 2. Okay. What do you mean? No. I mean, it depends on what xy range given. Yeah, maybe they will give you that kind of domain. I'm not sure. Right. Okay. So the whole set here becomes what? So you use dr, dz, dr, d theta in this case. So what's the Jacobian factor here? Huh? It's just r. Okay, so it become r. So you integrate 0 to 2 pi for theta, 0 to 2 for radius, and then r to 2 for z. And then what happened to our function x squared plus y squared? R squared. Okay, good. So you integrate this whole thing here. So you are just integrating r cubed. So in the end, you will get 16 over 5 pi. Okay, you get 16 over 5. Okay, you get 16 over 5. Huh? Rehat, any question before we break? Want to watch video or not? Question? Actually, we need to decide one thing. Next Thursday is public. So we need to replace. So next Friday can or not? Next Friday. Friday. Next Friday. Huh? Next Friday? Haji Thursday. Haji Thursday. Friday one or not? Friday, can we do 3 hours? Friday 3 hours. Because I don't know, I scared I can't finish. 5 hours. Last time we do 4 to 6, right? So this time we do 3 to 6. Or you will prefer later? 3 to 6? 3 to 6. 3 to 6? 3 to 6. I go and book 3 to 6 next Friday. Okay, next Friday. Is it okay? Majority okay? 3 to 6 next Friday. Okay, 3 to 6 next Friday. Okay. Okay, I'm happy with this integral here.
有个问题吗？没有。
Yeah.
假设说现在没有这个图了，
Yeah.
我要画这个出来嘛？
Yeah.
我一 confuse 这个
不要看这个图片，
对啊，不要看这图片，
不要看
这个东西要画
看这3个图片，
这东西要画出来吗？
要画出来，要画出来。
X 是根据这个 x 规加 y 规，然后这个
没有，根据这个吧，这个没有东西的，根据这边吧。
我知道。然后我一个问题是哦，就要你得出来这个 r 是20嘛？
对啊。
可是如果你这样看的话，这个 r 不是只有上面是？
对，但是问题是你取全部的 z，
取全部的哦。
对，取全部的 z， 然后
因为我这个在我
对，
可是这个 r 只有上面是20嘛，下面是？
你给我想一下，才跟你讲，没有，因为你看我是从0到2，我每一个 radius 我都拿。
0到
就是0到2的我都拿。
哦
但是怎么拿呢？在0的时候，它就是0哦。
啥意思啊？
嗯
呀
，OK， 你看这个，你知道这个会给你什么吗
？2派一个2派圆圈，一个圆圈呢？
对啊，一个圆圈哦。如果我没有拿0的话，就是一个圆圈拿掉中间那个点哦。
如果我没有拿对，哦
呀，
因为现在有这个 Jack 的存在，所以就
Z 的存在只是帮助你
变成就是一个 con
帮助你变成 con 罢了。下面2个是 this 来的。
对啊，是 this。
对。
哦，OK，
呀，
拜拜。
呀 ，OK。
老师，就是对于你Sphere 的那个解释，就是我想依照我的理解嘛，你说这个 A 这个 V 然后你把拉成类似于是斜。
OK， 好，这么快就走。
你看我们2个都来过了，
要走了，走去哪里？你这样子算是点名哦？我觉得不太合理诶。
好。那就等点完名再走是吧？
不是，等放完学再走。那 I mean， 我觉得你这样大了，我不需要教你怎么来上课诶。我觉得我不需要教你怎么来上课吧？你这么大，
没有必要上课。
那你没有必要，你可以跟 AA 说，你不用跟我说。你其实不用跟我说，你跟 AA 说就好。好。叫什么？
我要这个是
OK，
就是输入头。16。
OK， 好。对啊，我 I mean， 对吧？I mean， 对啊，对。如果你真的不想上课，你就去跟 AA 说。你跟他说这个课没有必要上，你跟他说。你跟他说。
就是我的理解就是，比如说这个地方，也就是说这是0，然后呢这是派，对吧？就是你说只需要接到派，所以我就是说0的时候它是不是就这样？然后呢现在就这样，然后到2派的时候它就在这。
对。
然后呢？
喂，对。
所以整个就是一个球体。
没有错。对。
我会这样弄下来的，因为我之前理解就是我之前理解是这个球体，然后呢有个沿 z 轴的纵剖面，然后呢它是这样子旋转，所以就只能有个0到派，但是其实看来是这样，是吧？
对，看你怎么，所以，OK， 一开始其实我不知道你怎么想那个东西，你在想刚才那个东西的时候，你是哪一个点这么撞，还是哪一个点这么撞？
就是我想是 x 这个是 y 嘛，然后呢这里最开始有个圆，然后你不是说以这个地方为0吗？就是 positive c。
对。
所以我想的就是，这个圆呢，它就这个这一块地方这个圆，它在0的时候它就这样，然后它在 顺时的话，它2/派它是这样，然后呢，派的时候它就这样，然后这样就转完，从0转到派就转完了一整个球。
哦，你要那样子想也可以啊，那样子想是可以的，那样子想是可以啊。那你那样子想，你是 fix 了所有的滴答过后，你才开始转派的，对不对？但是我的想法是我先 fix 了 B 过后才转滴答，所以一样的，一样。
但是你那个的话是，就是我这个是旋转，
可以啊，
穿
没问题啊。
但是按你刚刚说的话，它是就是
没问题
这样子滴下来。
一样的东西。
但是如果是这样子的话，如果按我的来想，它是旋转的话，那么从0到派的话，它旋转的这个东西，它就是这样的，它就是这样的呀，它就是对吧？你想，对吧？它击出来的是一个这样的，击出来的是一个
没有啊，没有啊，
这样子。
就你有这一圈了嘛，对不对？然后我要 0到派嘛。
对啊。如果它旋转到派的时候，
你给我想想，你给我想想。OK， 你这样子想的话，你应该要想减派到对，减派到派。我想想，这个想想，减派 over 2到派 over。
哦。
减派 over 到，我想想，对吗？这个我想想啊，对，应该没有错吧？减派 over 到派 over。
那如果那样子的话 ，positive z 就不是0了，而是
对。没有，我想强调是这边的 angle 跟这边的 angle 嘛，对不对？这边到这边是减 pi over 2嘛，然后这边到这边是 pi over 2，对不对？所以表示你要填满这两个。
那就是比如说这一块，就是如果按我想说的那样子的话，它是0的时候它在这儿嘛，对吧？
对。
然后呢，它的派是它的，
对。
就它从0转到派的时候，那它转出来的其实就是这两个东西。
对，然后你再继续转咯。
对，这样的话就出不来一个，
对，
出不来，就是它出来是这个东西，0到派它就出不来一个这个东西。
OK， 如果你是这样转，就出你刚才说的东西；如果这样转，是出另外一边哦。所以你要转到完，就不止转你刚才说的那个东西，再继续转哦，就完了。
这样
呀，
继续转的话
你
就
从这里转到这里的意思是这里转到这里。呀，所以你拿这一圈，
就是如果它再继续转的话，它就转出整个球。
对。
那就没有那个半球体了。
对。
对，但是如果按您的说的，就是如果是这样子记的话，它从0到派可以击出一个半球体。
但是你刚才就继续转，你也能够转出一个球体。
那只能转出个球体，不能转出半球体。
为什么要半球体？我们现在要球体不是吗？
我的意思说，就这两种不同方法的话，如果是
不同方法，它只是你只要给不同的那个 range of v，你就可以转出，
球体。
对。
没有半球。
对。
就是如果按这个击的话，是可以击出半球体。
我也可以击出半球体啊，我转一半就好，我不要转全部嘛，也行。就是看你怎么去控制那个 θ 跟 phi 吧。
但是如果按我说的旋转的话，它转一半，
对，
它转不出半球体，它
也转不出半球体，也对，对，没有错，
转出是一个错位的上面一个
对，没有错。
Spherical。
OK， 我觉得要开始了啊，
就是
来，
它这个 Cylindrical 它积分过程是不是先把它继承一个像西瓜一样的东西，就对于这个底继承一个像西瓜一样的东西，然后再把它转一圈，是类似这种过程。然后这个 Spherical 我看一下它的记录，这个图我看就是针对那个row 7的话，就是一个西瓜，西瓜一半，DC 它是转就是然后对，老师这个可能读 5 吧，我感觉。
什么？
这字母应该是读 5的吧？不是读 P 的吧？
对，5，
我不知道，好像我以前听到的声音就是读法都是读 5的。对。 delta phi 它是怎么写的？就是
有了。
对，就是对，它的 d phi 它是
等下我要开始了，等下再问可以吗？
好像是等于你刚刚在查的。
可以查一下。对，放一次可以要。对，放。好了。Okay. Hey, why gone again? 一。上行 thank you。
会啊，老师，怎么好？
哎。Okay. Let's try this. See video. You guys want to see video?
有时候看一些猫是两个也很有意思。
I watch this video.
Watch this。你还给我们看？
会啦，
可是你唱歌啊？
会啦。
So why you don't want to sing 啊？I hear you sing for one sing。
会啦。Hey, why no sound 啊？Why no sound here?
share 你 share，没有你 share，没有你 Microsoft Team 你 share 那个，你不要 share 那个 screen。
对。不听，等一下，太多东西要搞。
在直播出来就不一样了。怎么讲？这讲是什么啊？那是看不懂就是看。
哎，here。
这里是不是？
啊，
懂啊？喂啦。喂，不yet. Hey, where's why my browser gone? 喂啊 ，sorry 啊。喂啦。Guys watch before or not? 啊？Here. Yeah, later repeat. Yes, start again. Start again.
Yeah. So you are given they say you are given the exam sheet, right? But will definitely come out a question that you never answered before. What? Huh? I should give a MATC this. Huh? Next time I let MATC this. Huh? Is it? I don't know. I only see this version. Okay, you can send me later. Okay, so next, find this volume of solid that lies above the cone, z equals to square root x squared plus y squared, and then below the sphere, x squared plus y squared plus z squared equals z. Okay, so what's this triple integral asking? Asking about volume. Okay, doesn't give you a function. So what is the function you need to integrate over? What's the function you need to integrate over? What's the function you need to integrate over? Z? Not Z. Not Z. Not Z. So if you want to find an area of a domain, right? You double integrate over 1, okay? But you want to find volume of a domain, you also integrate over 1, okay? So you integrate over 1. Okay, so now how you fix your integral here? So what kind of coordinate you want to use? Oh, okay, wait. So yeah, so how you what coordinate is more convenient to use? Sphere. Okay, use sphere. Why? Because this is looks like a cut off sphere. Okay, cut off sphere here. Okay. So to find the sphere, okay, to find the sphere, so you want to change it to rho, theta, and phi. Okay. So how you decide your radius, angle, theta, and phi? Okay, how you decide this? How you decide this? Yeah, so you need to find where the range of the sphere here. Maybe which one is easier to determine first? I think the angle is, the theta is easier, right? Because you need to take everything from 0 to 2 pi. Okay, so this one is easier. How about phi? Do you know phi or not? Yeah. 0 to pi over 4. So how to get this pi over 4? You know what? How? You know how to get this pi over 4? I have no idea. Okay. So what's this phi here? So okay, let's write down the change of variable first. So the question here is how to find phi. Phi. Okay, phi or phi. How to find phi. Okay, how to find phi here. How to find phi? Don't know.
Phi square.
Yeah. Not guess, not guess, not guess. Okay, so try and play around with this equation. I play around with this equation. So first equation will become what? 5 squared equals to 5 cos theta. Phi, sorry, this is 5. This is 5. Right? Right? Because x squared plus y squared plus z squared equals to 5 squared. Okay, so this implies that phi equals to cos phi. Rho equals to cos phi. Okay, so this function here become a function in phi. Okay, how about the bottom part? How about the bottom part? So the bottom part is the same or not? So the bottom part is what? Rho cos phi equals to rho. Okay, which means not rho, x squared plus y squared. Okay, is what? X squared plus y squared, what do you get? You get rho sine phi. Right or not? Okay, let me write out. Okay, let me write out. Okay, z equals to square root x squared plus y squared. So z is rho cos phi equals to square root the whole thing rho sine phi cos theta squared plus rho sine phi sine theta squared. Okay. So all together, what do we get? We get rho sine phi. You get it? Okay. So all together, what do I have? I have cos phi equals to sine phi. So when does cos phi equal to sine phi? This is when the tangent phi equals to 1. Okay. Makes sense or not? Okay. And then when does tangent phi equals to 1? Or when phi equals to power 4. So this is how we get power 4 here. Yeah. Okay. Better. Okay. So how about rho? How about rho? Okay. Rho going from where to where? From 0 up to the sphere. Okay. But how you control the sphere? How do we control the sphere? What's the sphere equation we have? Cos phi. Okay. So this radius here is controlled by my phi. Okay. Phi. So it's from 0 to cos phi. Okay. Any problem of getting this domain here? The most important part is how to get this domain. Integral should be just the usual integral. Any problem with getting this domain here? We try to find the easiest variable to fix first, okay, and then slowly we fix the others. Yeah.
Radius sign.
Radius sign is 1. Which one? I mean, this tangent phi is 1. Why is the tangent phi is 1? Because we get that cos phi equals to cos sine phi. Because we get cos phi equal to sine phi. Yeah. Okay. How we get this is because of the bottom column here. This equation z equals to square root x squared plus y squared. Which one? Rho. How to get rho? Get rho equal to cos phi. Okay. This one is the part that explains the sphere. Yeah. This is the part that gives you the sphere here. So this sphere is x squared plus y squared plus z squared equal to z. Okay. And then you sub all these change of variable inside here. You can reduce this function to just rho squared equals to rho cos phi. Yeah, after simplification, you get rho equals to cos phi. Okay. Why? No, your rho cancel out already because you get rho cos phi equals to rho sin phi. Rho and rho cancel out. I think can. Yeah, you can do that. You can do that. You can do that. Yeah, you can do that. Yeah, you can do that. Yeah, you can do that. Yeah. Yeah. But when you do that, right? Oh, if you split this into two parts, right? Okay, if you split into two parts, okay, the way you split it, it must only intersect at the boundary. Okay, the boundary in this case here is the unique circle. So you can split into, okay, let's put here D1, here D2. Then your integral will split into integrate over D1 and plus integrate over D2. Okay, provided they only intersect at the boundary. Okay, they only intersect at the boundary. Okay, you cannot intersect like this. This one cannot. See that they have some extra stuff coming. You only intersect at the boundary can. Okay, so in this case is this can. Yeah, can. Yeah. Yeah, so I mean this is the volume, right? Okay, so actually you can just compute the sphere and then divide by, if you know that this is half, just half of it, then you just divide by 2 and then you add out the cone volume also can. Right? Yeah. Yeah, so you ditch the triple integral in this way. Yeah. I mean, if you know what happened to the sphere and the cone here, then you can know everything without doing the triple integral. Okay, but do triple integral, you need to use this range here. Okay, so altogether, what do you get? Okay, so let's see what happened to our integral. Okay, so what happened to our integral here? So this becomes an integral from 0 to pi over 4. Integral from 0 to 2 pi, 0 to cos phi of phi squared sine phi d rho d theta d phi. Okay? Yeah. So you only have this Jacobian stuff coming up, but multiply by 1. So you just solve this, and then in the end, you will get pi over 8. Equation is 1. Oh, okay. Yeah. So this is a triple integral, right? Okay. So triple integral, you want to get volume of a 3D solid, then you just use the function 1. Remember last time when we do the double integral, okay, how do we compute the area of a domain? Okay, we integrate over the domain of function 1 over dA. Remember or not? Okay, because why? Because you have your domain D. If you multiply by the height 1, you still get the area. Because D times 1 is still D. Okay, area of D times height 1 still D. Huh? No. Depend on what integral you look at. Here we are looking at double integral. Just now we look at triple integral. triple integral integrate over 1, you get the volume of the domain. Not 1. Some random equation, then you will go to higher hyper volume. Remember just now, remember this one, if we replace this F with a positive surface, then we will get the volume over the area. So you get a one-dimensional higher thing. Okay? Okay. Okay. Yeah. So you see this picture here? So this gives you a way how to think. We slice it up. Okay. So this is the, if you make this a whole sphere, this is what I'm talking about just now. Yeah, you also can think of the hot air balloon. Okay, the hot air balloon, you see, got the slices, right? And then the hot air balloon will like turn. If you want to find volume of a solid using triple integral, you need to integrate over 1. If you want to use double integral to compute area, then you need to integrate over 1. So wait me finish first. So you see, so volume of D triple integral over D. This is the property. Okay, because why? It's very making sense here, because double integral here is already a domain, already 2D. Okay, so you already integrate over the domain already. You just want to get the area, then you integrate over 1. Okay, the height is just 1. Okay, so you see. Okay, let me show you something. So let's see, this is a square. Okay, what's the area of a square? It's 4. Okay, area of a square is 4. Okay, how about area of a box with a height 1 with this square as a box? This volume is what? So with a height 1 is also 4. Okay, so you see this area is equal to this volume here. Volume of a box with height 1 with the same base. Okay, so this is the idea here. Okay, although you are computing something volume, but you still get the area number. Okay, the idea is like this. Make sense or not? The volume of a box with height 1 have the same value with the area of its base. Okay. Yeah, Ho Ming. Yeah. 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 Similar is similish. Yeah. Okay. 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 So now let's introduce what is this Jacobian thing. Okay. Yeah. So finally we reach this Jacobian. So first of all, we start with a 1-to-1 transformation. Okay. 1-to-1 transformation. So like what we did just now, we pick the range and then we did the change of variable. So the change of variable just now are the 1-to-1 transformation. So for example, let's give you an example. So just now we say that in polar coordinate, right, we have x equals to r cos theta and y equals to r sine theta. Okay, so we have the notation here. So what's this t? So this t will add on the new variable. Okay, and then it will tell us what happened to the old variable. So in this case here, x is becoming r cos theta and r sine theta for y. Okay, so this is our 1-to-1 transformation. 1-to-1 transformation. Okay, so the theorem here is if we change the coordinate, okay, you will get an extra Jacobian here, absolute value of Jacobian. So what's Jacobian? Okay, just now we keep mentioning. So Jacobian here, you look at all the first derivative, partial derivative. Okay, so you look at the variable in the codomain. Okay, partial differentiate with respect to the domain. Okay, so you arrange. So how do you arrange it? So how many? Okay, so how many partial derivative you have when you differentiate the codomain variable with respect to the domain one? How many do you have? You differentiate two variables with respect to the other two variables. So in total, how many partial derivative you have? 4. Okay. So you have dx, dr, dx, d theta, dy, dr, dy, d theta. Okay. So the problem here is how to arrange your Jacobian. So you arrange your codomain in a column. Okay. And then you arrange your variable in domain in a row. Okay, so this is the Jacobian. Okay, so this is the Jacobian. And then you need to take the determinant of this matrix. Yeah. Okay, so let's see this. So remember what's the Jacobian for polar coordinate just now? When you swap to polar coordinate. What's the Jacobian? What's the extra factor? R. Okay, so let's see if this compute to R or not. Okay, so what is dx dr? Dx dr here is just cos theta. Okay, how about dx d theta is minus r sine theta. Okay. How about dy dr? Sine theta. Okay. How about dy d theta? R cos theta. Okay. So all together we have cos theta and then minus r sine theta. dr is sine theta. And then r cos. Okay. So you get what? So you get r cos square theta minus plus r sine square theta. So you get r. Okay. So the Jacobian for our polar coordinate is r. Okay. So if you briefly want to know what's the concept here is because if you change, you can see that in this diagram here, if you change coordinate, you see that this rectangle here become a banded rectangle. Okay. But we only know how to compute the area of the rectangle, right? Only length and width. Okay. But how to compute this banded one? Okay. So to compute this banded one, we need to unband it. Okay. So if we unband it, we bend it back. The extra factor introduced is r. Okay. For each piece of rectangle, we have this extra factor here. Okay. So we need to bend it back to a proper rectangle so that we can compute the area. Okay or not? Yeah, this is just concept. I didn't show you explicitly what happened. No. It's differ by this factor r. Differ by factor r. Differ by factor r. Yeah. Differ by factor r.
Differ by factor.
Yeah. Differ by factor r. Okay. Differ by factor r. I mean, after you add out r, then it will become the same. Yes. You need to compensate with this Jacobian to unband rectangle. Okay. How about we see the example next next lecture? Okay. Okay.